Here is an example of a Bronsted acid-base reaction. Hydrogen fluoride reacts with water to form hydronium ions and fluoride ions. Since HF gives away a proton, we can identify HF as the acid. Water accepts or gains a proton, so we identify it as a base. But notice we write this as a reversible reaction. For the reverse reaction, hydronium would give the proton back to fluoride to reform the reactants. So for the reverse reaction, fluoride would be the base and hydronium would be the acid. In this reaction, we would say that the conjugate base of HF is fluoride ion. That's what's left after the proton has been donated. Likewise, H3O1+ would be the conjugate acid of water. It's what's formed after water gains a proton. Thus we talk about conjugate pairs. The acid-base pair HF fluoride is a conjugate pair. The acid-base pair hydronium water is a conjugate pair. Notice that conjugate pairs differ by one hydrogen and one unit of charge. So if we have an acid, we should be able to predict the chemical formula of its conjugate base. And if we have a base, we should be able to predict the chemical formula of its conjugate acid. This will directly help us in writing balanced equations, since the products of a Bronsted acid-base reaction are the conjugates of the reactants. Let's do just a few examples to see how this works. Let's say that HSO3 1- acts as an acid. What is its conjugate base? Well, if it is acting as an acid, it is giving away a proton, so its conjugate base will have one fewer hydrogen, and since it's giving away an H+, the charge will go one step more negative. So the conjugate base is the sulfite ion. If NH3 is a base, that means it will accept a proton, so its conjugate acids should have one more hydrogen and one more positive charge. The conjugate acid of ammonia is the ammonium ion. H2CO3 is an acid. After it gives away an H+, we have HCO3 1- remaining as the conjugate base. Yes, HCO3 1- could give away another proton, but conjugates are defined as differing by only one hydrogen and one unit of charge. What about sulfide as a base? Again, because conjugates differ by one hydrogen, its conjugate acid is HS 1-. Water can act as an acid. After giving away a hydrogen ion, its conjugate base is the hydroxide ion. Water can also accept a proton acting as a base, so the conjugate acid of water is the hydronium ion. Water is a chemical species that can act both as an acid and a base. Materials like these that can go both ways are called amphiprotic.